For your warm-up today, I handed you guys, or they were already at your desk, but you had these blue paper rulers, and I asked you to measure the thickness of your desk and the length of your palm in centimeters. Did you find this ruler easy to use? No, not really, because this ruler only has whole numbers of centimeters marked on it. Okay, that makes it harder to use because it's harder to tell exactly what it says. There's a degree of uncertainty in this measurement. And so you're having to estimate, okay, about what you think it is. Since you can see whole numbers, you can say, oh, it's about maybe 2.1, which by the way will show up as a correct answer if you type that. Or 2.2, which will also show up as a correct answer if you type that. If you just typed 2, it's going to count it wrong. Okay, you need to estimate to 1 decimal place because that is 1 place farther than the smallest marking on the device. The smallest marking on the device is the 1's place. 1 place more than that is the 10th place. That is 1 decimal. Okay, but it's a little bit difficult to use. There's a degree of uncertainty here. When you guys, or I say when you guys, some of you guys are in chemistry right now, correct? Do I have sophomores in here? Yeah? Okay, so some of y'all are taking chemistry right now, and you will be talking about this. The rest of you learned about something called significant figures last year, and I'm sure it's just bringing back flashbacks. Okay, hopefully your chemistry teachers explained to you why you were using them. Okay, if not, I'm about to right now. Okay, we use significant figures to express how certain we are about a measurement. In this case, because I can only see whole numbers of numbers on this device, I'm going to estimate 1 place further. So my measurement should have had 2 significant figures in it, which shows that how certain I am about that measurement. If I used a normal ruler that had all of the millimeters marked on it, then I could give you a more precise reading, okay, from that. But with this ruler right here, would it be appropriate for me to say, oh, this desk is exactly 2.17 centimeters? No, because you can't see to that degree of precision. You can't see that many significant figures. Those sig figs told you how certain you were about your measurements. If you then had to use that measurement later on in a calculation, you still couldn't be any more certain about your answer than you were when you first took the measurement. You can't get an answer at the end of some calculation and say, oh, the answer is 17.254. You don't know that degree of precision. Okay, and that was the whole reason behind using those significant figures in the chemistry class. The good news is we don't really use them as much in physics. That is definitely something you have to do in chemistry, but in physics we'll just, sometimes I'll tell you, give me 3 sig figs in your answer, but it's not going to be something where you have to do it every single time like you did in chemistry. So if you hated that, well, the good news is you don't have to do it all the time. But I do want you to have an understanding of why we do that, and I do want to incorporate that into our discussion of accuracy and precision, because it does absolutely relate to precision, specifically when we're talking about precision of a measuring device. Your palm, I think if you put anything between like 9 and 23, because our hands are all different sizes, but I figured nobody's hand was smaller than this and nobody's was bigger than this. So, I mean, you might be, but it should have counted that one right for you as long as you put something in there in that general range. But again, make sure you have those answers in there. And we are going to go through some notes today on unit conversions, scientific notation, and then your assignment that hopefully you started yesterday. If not, you'll just do it today, on graphing and reasoning in MyOpenMath is due by 11:59 p.m. tonight. It's not due during class today. It is due before midnight tonight. Okay, so hopefully you finish it before then, but if not, you can do it whenever you get home. All right. So let's go ahead and jump into those notes. And again, I think we looked at this yesterday, but precision of a measuring device is kind of the point of the warm-up, was getting back to this right here. This device on the left is more precise because it has more graduations, more marks. The word graduations just means the marks on the device. It's why that thing that you used in chemistry was called a graduated cylinder, because it had a lot of graduations on it. Okay, but the more graduations you have, the more precise your measuring device is. This particular device, what would be at your doctor's office on the left-hand side, would allow you to estimate your height to the nearest hundredth of an inch if you really wanted to. Okay, on the right-hand side, on the other hand, is just a strip that goes on the door frame at like a convenience store in case they get robbed, and then they can say the suspect is about 6'2", because they're looking at it next to that right there. That does not have very much precision, but it's good enough for that purpose because you don't really need to know he's exactly 6'2.5". That doesn't really matter. Okay, but it's not very precise. It has few markings on it, so you can only estimate heights to the nearest inch. Okay, you always need to estimate one place beyond the smallest mark on the device. Whenever we talk about our measurements, obviously we've just been talking about feet and inches, but we're going to be using the metric system. And you need to have an idea of what our international system of units for science includes, and these are our 7 base SI units. And so for length, mass, time, amount, temperature, current, and luminous intensity, you can copy down each of those. However, I will just tell you right now, we're not going to use moles in here. That's chemistry. We are not going to use candelas. We don't do luminous intensity. So if you don't want to write those two, that's fine. We don't really do a whole lot with temperature either, but you can write down the Kelvin if you want. You could see it. The rest of them you will absolutely see. We do measurements of length in meters. We do measurements of mass. I just want to point out for mass that our SI unit for mass is a kilogram. Okay, the base unit for mass is a gram, but the SI unit is actually a kilogram. Okay, for time, we measure the SI unit in seconds, and then electric current in amperes or amps. Okay, and you will see all of those in this course. I want you to recognize what these symbols are because sometimes you're going to see a metric prefix in front of them. In fact, there's a metric prefix right here in kilogram. Kilo, it's a prefix. Okay, and so those prefixes have meaning, and one of the things that we need to go over today is what those mean and how to do conversions with them. If you tried the assignment last night, 104, you probably already noticed that there were metric conversions in that assignment. Okay, and so you do need to be familiar with the metric system enough to do conversions with our most common prefixes, which I'm going to show you on the next slide. Okay, these are really the only ones, well, not the only ones, these are the ones you need for now, okay? The ones that are in red, kilo, centi, and milli. Those you should already be familiar with anyway. Okay, otherwise, the only other ones that you're going to see, and you'll see next semester, nano. Whenever we start measuring wavelengths of light, they're very small. The wavelength's very small, and so you'll see nanometers for that. So you'll see nano. You might see micro, okay, the one that's right above nano. And we could use mega at some point, like megahertz, whenever we start talking about frequencies. So those are the ones that you might see. But the ones in red, you definitely need to know, forwards and backwards, because you're going to see them throughout the entire year. Okay, so you need to know that kilo is your base unit times 10 to the third. So a kilometer is 10 to the third meters. Okay, it's 1,000 meters. A centimeter is 10 to the negative 2. It is a hundredth of a meter. Okay, a millimeter is a thousandth of a meter, 10 to the negative 3. Okay, and so you do need to know the conversions for those three. And the prefixes as well, because if you see kg, that's kilogram, km, kilometer, you need to recognize k is kilo, you need to recognize c is centi, you need to recognize m is milli. And again, if you want to also write down micro is a Greek letter called a mu. That's what you see right there. That's what we'll use. I know it says or MC. We don't use that. We use this one, mu. And then nano is an N, if you want to write that. Mega is a capital M. You'll notice that you need to capitalize it because milli is already lowercase. Okay, so if you want to include that one, you can. We don't use pico or deci, so you don't need to write those down. But if I asked you, so whenever we report our measurements, you need to do it in units that make sense. Sometimes I'm going to tell you, give me your answer in meters. Other times, I'll just say how far, and then, it would be silly for you to tell me, that the distance from the school to your house is in centimeters, for example. That'd be crazy, because it'd be a really big number. So sometimes you just need to give me units that make sense. So if I asked you to measure the distance from the school to your house, what unit should you use? Obviously, it's not centimeters, as I just said that. But what do you think metric unit-wise? I know, not miles. Metric, what should we use? Yes. Yeah, kilometers. Okay, kilometers would be the most logical unit for measuring a distance between school and your house. Here's an example. If my house is 8,735 meters away from school, how many kilometers away is it? So this is an example of when you might have to actually do a conversion. 8,735 meters, we're going to convert that to kilometers. And if you took chemistry, maybe you already saw that on my board up there, then you already know that we're going to use a process called dimensional analysis. If you haven't taken it yet, I would definitely copy some of these examples down so that you can look back at them, because again, your assignment's going to ask you to do this as well. So I'm going to work this out. I'm using the document camera this period instead of the board so I can record it. Okay, so we're going to convert 8,735 meters to kilometers. Okay, and to do that, we have to use a conversion factor, which was what we just looked at in the table. That table that we were just looking at of metric conversions told us that there are 10 to the third meters in 1 kilometer. That's what it said on there. This, by the way, is 1,000 if you'd rather write it that way. And so that is now a conversion factor that we are able to use to convert from meters to kilometers over here. You might have your own process for doing this, but I am going to show you the way that you would have done it in your chemistry class last year, same thing, using dimensional analysis. And so when you did that in chemistry, you took your number that you're given in the question, 8,735 meters, and you multiplied it by a fraction, which was your conversion factor. And you had to do so in a way that allowed you to cancel this unit and to get the unit you wanted. I want kilometers. I need to cancel meters. This is not focusing. There it goes. And so I'm going to plug this in as a ratio. They're equal to each other, so I'm not changing the value of my answer. I'm just changing the unit. And so I'm going to put 1,000 meters down here, and I'm going to put 1 kilometer up here, and I'm doing that because it allows me to cancel that unit. Okay, and get kilometers. And if you looked at this logically, you're like, okay, I have 8,735 meters and I want kilometers. There are 1,000 meters in a kilometer I need to divide. And maybe you did that. That's fine. Okay, and for this one, that's easy enough to do just logically in your head. Sometimes, though, it's not as straightforward. And so if you set it up like this so that it cancels, you'll be good every time. By the way, in chemistry, they probably didn't write it like this. They may have. But a lot of times, instead of writing times a fraction, just to organize the data better, you'll see it like this. Is that how they did it in your chemistry class? Yeah, same thing. This number times this fraction. Same thing, just a different way to write it. Okay, and so if you were doing that, you would just, in this case, multiply by 1 over 1,000, which is the same thing as simply dividing by 1,000. So I would do 8,000, and you probably don't need a calculator for this, but I'm going to show you anyway. 8,735 divided by 1,000. Which gives us 8.735. My unit, of course, is kilometers. Hopefully you didn't need a calculator for that, but I'm just showing you the whole process. Okay, so again, this is how we are going to do unit conversions, and you will have unit conversions throughout this course as well. They just won't have moles in them. Okay, so good news for that, I guess. All right, standard unit for mass. I showed you that chart a second ago. That one was the one that was kind of weird. It was kilometers rather than just, or not kilometers, kilograms rather than just grams. Okay, so our standard unit or SI unit for mass is the kilogram. Okay, so if I asked you to measure a single grain of rice, do you think kilograms would be appropriate? No. Rice is very small, so kilograms wouldn't make much sense. Okay, we could start with grams, and maybe it needs to be smaller than that, maybe not, but definitely not kilograms. In fact, here is at least the average. I Googled it. If an actual grain, mass of a grain of rice is 0.021 grams, convert this to the standard SI mass unit. So we're going to convert this to kilograms, which is silly because a grain of rice is so small. But let's go ahead and try this conversion. So we're going to take, I think I actually have this on another slide. I have it right here. We're going to take 0.021 grams, and we're going to multiply by a conversion factor. There are 1,000 grams, or 10 to the third grams, in a kilogram. So it's the same conversion factor we used a second ago, except now we're with mass instead of distance. Okay, and so this ends up being divided by 1,000, which means we get this, 0.000021 kilograms, which is kind of a long number to write because it has so many zeros. Does anybody know how we might express this answer differently?
To the negative.
You're on the right track. You know what that, I don't even need the answer. Do you know what that is called when you convert it to that form?
The negative.
Scientific notation, yeah. Okay, so scientific notation. In fact, if you type it in the calculator, which I did, I took a picture of my calculator screen, you get 2.1e negative 5. This is the way that your calculator does scientific notation. Okay, is you're going to see an e. What that means is the same thing as what is written up here, 2.1 times 10 to the negative 5th power. So this is 2.1 times 10 to this exponent, negative 5. Okay, so you need to recognize that in the calculator because if you're doing math in the calculator, you need to be able to take that answer and put it on a test or a quiz or a worksheet or whatever. But for numbers that are really big or really small, scientific notation is a lot easier to use than writing out all of those zeros. And so if you have something like this, and your calculator will do it automatically if it's really big or really small, so you need to know how to read it. But this number would be easier written as 2.1 times 10 to the negative 5th kilometers. If your exponent is a negative number, like negative 5, that means your number is really small. If it's a positive number, like positive 12, it means your number is really big. Okay, but it's the number of places that you're moving the decimal either to the left or to the right. Okay, if you want to do it that way. Okay. You can also evaluate your answers for reasonableness whenever you do a conversion. You guys, unfortunately, in the United States, we don't really use the metric system very often, and so we don't have a really working knowledge of what these things actually look like. Okay, so if I asked you how tall you are in centimeters, you probably don't know off the top of your head. And you probably don't know if this is a reasonable number or not. 173 centimeters, is that a reasonable number for a person? You may or may not know, because you may or may not have a good understanding of what a centimeter, how big that is, with respect to units you are familiar with. And so if I asked you to do something like this, you should be able to do this conversion. Okay, I just gave you a conversion factor. There are 2.54 centimeters in an inch. And so you could use that to figure out your height in centimeters. By the way, 173 centimeters tall is a reasonable number for a person. It's about 5'8". Okay, and that is how tall I am, so that's why I put that up there. So yes, that would be reasonable. Okay, and you can do that conversion on your own if you like. I'm going to kind of skip through some of this. But you need a working knowledge of the approximate size of measurement so that you can evaluate for reasonableness. Because if I did this calculation and I got like 1,730, then I would need to know, oh wait, that doesn't make sense. And that way you can identify that you have an error before you get it wrong on a test or something. Okay, what about this one? A student averaged 67 meters per second on a road trip. What was the student's speed in miles per hour? Is that reasonable? I actually have this one still written on my board from last period. Okay, but if we're doing this conversion and you wanted to figure out if this is reasonable or not, okay, first of all, you'd need to have some understanding of what 67 meters per second would look like. Okay, y'all have about, y'all hopefully have a working knowledge of like the size of a football field. Okay, a meter is about the same size as a yard. So if you're driving, because it's a road trip, the question is it reasonable for a car to travel like 2/3 the length of a football field in a second? Okay, and maybe you can picture that and maybe not. It might be easier if I asked if a person could run that fast, so that's obviously no. Okay, but we can calculate this for a car, and I already have it written up on the board, but I'll go ahead and work it out again by hand. 67 meters per second. We're going to convert it to miles per hour. So 67 meters per second. We're going to put the seconds on the bottom because it's a fractional unit. Okay, and we need to convert to miles per hour. And so we're going to convert meters to miles and seconds to hours. There are two different parts to this calculation. It doesn't really matter which one you do first, but I'm going to go ahead and start by messing with the distance unit. I know that there are 1,000 meters in 1 kilometer. So I know that I can do that. In fact, I already did that conversion once in order to cancel meters. And if I was to stop here, just divide by 1,000, I would now have my speed in kilometers per second, which I don't want. I want miles per hour. So I now need to convert from kilometers to miles, and that conversion factor was on the screen a minute ago, but there are 1.61 kilometers in 1 mile. Okay, and so again, I can cancel that unit. And now I have miles for my distance unit, which is what I want. MI, by the way, is the abbreviation for miles. M is meters, so don't mix the two up. All right, but I still have miles per second, and I want hours. To cancel seconds and get hours, do you know how many seconds are in an hour? You maybe don't, but you probably know how many seconds are in a minute, right? 60. So you can do it one step at a time, or you can do it all at once if you happen to know that. Okay, but there are 60 seconds in 1 minute. And you might be wondering why I put this on top. I did that because I'm trying to cancel this unit, which is on the bottom. So if you want to cancel it, you have to have one on top, one on bottom. Okay, dividing seconds by seconds is going to cancel it out. Now I have miles per minute, but I want miles per hour, so I have one more step, and that is that there are 60 minutes in 1 hour. Okay, and so that is the setup. And so now I have a series of fractions that need to be multiplied. Anything that's on top ends up being multiplied. Anything that's on the bottom ends up being divided. And so that's what I'm going to do right now. Okay, is 67 times 1 over 1,000. I'm just going to do divided by 1,000. I don't need to write times 1. Okay, times 1 over 1.61. I'm just going to write divided by 1.61. Times 60 over 1. I'm just going to put times 60. I don't need to divide by 1. Times 60. And we get 149.8 if it decides to focus today. You can do it. I don't know if it's going to focus or not. But it's 149.8136. There it goes. It keeps going. Is that a reasonable speed for somebody's road trip? No, not really. We don't drive that fast. Most of our cars probably don't go that fast. Is it possible? I mean, feasibly, if you had like a really fast car, but that's probably still not your average speed on a road trip. Okay, that would not be a reasonable answer. So if you see a question and you get like 67 miles per hour for the speed of a car, you're probably wrong, unless I gave you just some crazy number or a race car. Okay, so again, be able to evaluate for reasonableness. You can also figure out error from your measurement. So if you are off from something, then you can calculate your percent error, and this will allow you to evaluate how good your data is. Okay, the equation for that is up here, your measured value minus your real value. Absolute value of that is always going to give you a positive number, divided by what you should have got. So what you got minus what you should have got, divided by what you should have got, okay, times 100 to get it to a percent. But it's the discrepancy between the exact value and what you got, your approximation to it. So the example says, if the actual mass of a grain of rice is 21 milligrams, but my balance consistently finds the rice to be 17 milligrams, what is my percent error? And then, is my balance accurate, precise, both, or neither? Okay, so again, you can do this calculation pretty quickly, because you can just do 17 minus 21, absolute value of that. So you could just write 21 minus 17. That'd be faster. Okay, and then divided by 21, because that's the real. And that would, times 100 would give you your percent error. So let's go ahead, and I'm going to do that in the calculator. 21 minus 17, and then that's 4. Okay, if you did the other way, negative 4, absolute value is 4, divided by 21 times 100 is a 19% error. Okay, that's pretty large. We don't want our percent error to be over 5 ideally, definitely not over 10. So that balance is not very accurate, okay, because it's not right. Is it precise? It is, because it says that it consistently finds it to be that value. It's doing the same thing over and over again. Okay, so it is precise, but it is not accurate. All right, your assignment for today is to complete the assignment that you hopefully started yesterday, 104, Graphing and Reasoning Problem Set in My Open Math. You can work on it for the remainder of the class period. If you are not finished when the class period ends, which we're on advisory schedule, so your class period is going to end in about 14 minutes, but you guys have advisory in here, so you have that time as well, unless you are a senior, because seniors are going to the auditorium for a code of conduct presentation. But everybody else can continue working on that advisory if you want. But at the very least, you have the remainder of the class period. So if you will open up My Open Math and 104 Graphing and Reasoning Problem Set, you have until midnight tonight. It needs to be turned in by 11:59 p.m. Otherwise, you'll have to use a late pass, And if you use a late pass, it's going to automatically deduct 20% off of every question that you do late. Now, if you do half of it on time and only half of it late, it's only going to deduct late points off the half that is done late. So that's the good news. But that is your assignment. So if I were you, I would get that opened up. Now, word of caution, because you guys aren't super familiar with this website. I put all of these questions in here, and I actually program them in PHP. When I program them in there, I program them so that it gives you random numbers. Yours is not the same as your neighbor's. Okay? If you look at theirs, they're going to have different numbers than you. The answers are also scrambled. I also typically program it so whenever there's a picture like a graph, there are at least 4 different ones. So your assignment is not the same as your neighbor's. Point being, do not copy them. Don't say, hey, what did you get for number 2? It's not going to work out very well for you because odds are you have a different question, and even if you have the same question, everything is scrambled. Okay, so I do not mind at all if you work together. I welcome it. I encourage you to work together. I encourage you to help one another. But your questions don't need to be, what did you get for number 2? They need to be, if you're not sure, they need to be, hey, can you show me how you did number 2? How'd you do yours? Can you show me, can you help me how to do mine? Okay, that's fine. You are more than welcome to help each other. So if you're not sure how to answer a question, you are welcome to ask anybody that is sitting around you. If none of you know, then please raise your hand so that you can ask me, and I can come over there and look at it with you. It will allow you to attempt each question 2 times before you get a new version. Every time you answer a question, it is going, if you get it wrong, if you get it right, you get full credit. But if you get it wrong and have to do it a second time, every time you try it again, it's taking off 10% of the points. So obviously you want to get it right the first try. Okay, if you don't though, 10% is not a huge penalty per question. Okay, even if you got all of them wrong once, you'd still have an A. Okay, but if it's just one question, you're still going to have a high A if you get the rest of them right. But it is going to do that. So if you get it wrong the first time, it will allow you to resubmit an answer on the exact same question with the exact same numbers and picture 1 time. If you get it wrong a second time, it is going to ask you, there's a button that either says get a new version or get a similar question. I forget exactly how it's worded. But when you click that, you might have the same question, but you might not. It might change your graph. It might change the numbers, whatever. So just be careful if you have to click that. So anyway, go ahead and get to work. If you have questions, please let me know. Again, this is due by 11:59 p.m. tonight.